Okay, so in older style, we write a definition for this particular interface method. But now where are we writing? We are writing inside the main method itself. Inside the main method, we are defining a functional interface method in terms of lambda expression. And that lambda expression, we are passing it to the any method. Like if at all you use any method to call it, inside that method you are calling. Okay, so that is one way. And let's say another program. Okay, let's see this one lambda expression. It's a very simple thing. Okay, what is a functional interface? An interface with exactly one abstract method. And it can contain any number of default methods. It can also have static methods, but abstract method should be only one, because in Java 8 you have a concept of default methods. Means you can create a method with a keyword default. You can create a method with a default interface, my functional interface. You have annotated with functional interface, and this is an abstract method, and this is a default method. You can have any number of default methods, but abstract should be only one. Default means you have to provide the definition. Now here it is public class. This is interface part till here. Here interface ends. And this is lambda expressions with no parameter, main method, string arguments. Now say my function interface message equal to, see I am assigning to this my functional interface. My functional interface msg equal to, now see here, this is a lambda expression. I am assigning a lambda expression to a functional interface. Are we passing any parameters to lambda expression here?
No.
No. Okay. Directly we are assigning a lambda expression. Functional interface. Message is a reference, object reference for my functional interface. So to this interface, I am assigning directly a lambda expression. So it has to return hello. It has to return hello. Why? Because we are saying strictly this abstract method returns some string value. Now let us suppose you are not returning anything. See, it will give an exception. It says this method must return a result of type string, because it is a definition for this lambda, this for abstract method. This lambda expression is a definition for abstract method. So it should match with the definition of this method. Since it has a return type string, you have to return hello.
Okay.
Same thing. System.out.println message dot say hello. msg dot say hello. Okay. So here msg dot say hello to, we are calling. Let me print this. So this is say hello to, and this is say hello. Since it is returning, we are putting inside this system.out.println, because the definition is returning a value. That is the reason we are printing here, putting inside this. Or else what we can do, we can assign it to a string variable, and then we can print that variable, isn't it? Because it returns a string value. Message from say hello is, Okay, message from Sehel. Now let's say with single parameter. We have seen previously calculator with multiple parameters. Now I'm using two interfaces. Predicate function, its return type is abstract method is you have a return person type. Return person type. So here this is also a function interface, public string increment by 5. A function type, function interface, a method with single parameter. Usually you have a concept of all these functional interfaces. All these functional interfaces are categorized into different types. A functional interface can be a predicate. A functional interface can be of type function. A functional interface can be of type supplier. Okay. A functional interface of type consumer. There are different types of functional interfaces. Okay. So here we are using a predicate type of function. A predicate type of function. And here a function interface is of type a function. You have a concept of, let me save this. Functional interfaces. Functional interfaces falls into different categories. You can create a functional interface of type function, predicate, consumer, target, supplier, by function. These are some different types. By predicate also we have, I believe. These are different types of functional interfaces that you can create. It's of type function type, predicate type, consumer type, target type, supplier type, by function, by predicate. Um, these are the major types. Okay, so if you see now what is a predicate type functional interface? What is a predicate type functional interface? Interface predicate function. Now here a predicate type functional interface will return a boolean value. Will return a boolean value. Return person type. It is taking some integer. All this is okay. Method we know. But when do you call a functional interface as a predicate? If the abstract method returns a boolean value. If abstract method returns a boolean value, then we say it is a interface is of type predicate. Means either true or false. A predicate functional interface must return a boolean value. Means an interface, a functional interface is called as a predicate if it returns a boolean value, either true or false. Means basically predicates are used to test conditions. That's it. Predicates are used to test conditions. Okay, so this is predicate type interface and this is a function type. Function type will return any value. Interface, my functional interface. Okay, so public string increment by 5 means it is just like a normal function. What is a logic of normal function, or what is the definition of normal function? A function or a Java method can return any value or may not return. It may return, may not return. Okay, you got the difference between a predicate functional interface and a normal function interface. A predicate functional interface will return only Boolean values. Will return only Boolean values. The predicate functional interface will return only Boolean values. Function type function interface will return any type of value. Is this point clear?
Yeah.
Okay, predicate functional interface will return only Boolean value. It will return any type of value or may not return a value. Okay, so this is a major difference between a normal function interface and a predicate function. Means function type function interface and predicate type function interface. Okay, so here these are the two interfaces that we have taken, and here is our main method, and I'm trying to use my function interface f equal to, so I'm passing single parameter and performing some arithmetic. So this is returning a string value. So this is passing simple value variable number, and I'm performing some arithmetic logic inside the body of the lambda expression, and I'm trying to return a value. Now I have to print this f. Okay, so system.out.println f dot increment by 5 22. So here you are passing 22 here. You are passing, when you call system.out.println, it is just simply assigning a lambda expression. Now where exactly this execution will take place? Here execution will take place. Inside the main method, integer I equal to 10, and you are assigning some lambda expression just like a variable, and then you are trying to call f dot, this function interface dot, what is the method given? Increment by 5. What is the method given? Increment by 5. So you have to call with this name. Now here it will pass 22 to this line number 24, and then execution will take place. Is my point clear?
Yeah.
Similarly, here also you are assigning a lambda expression to predicate function pf equal to, you are assigning a lambda expression. Now when this lambda expression will be executed? When you call functional interface method. Now what is a functional interface method name? Return person type. Return person type. Is this point clear? Lambda assignment is different. Lambda execution is different. Now when lambda execution will be different executed? When you call functional interface method. When you call method, so where are you calling? Here you are calling. So lambda expression is executed here. This is simply assigning lambda expression. Here also same thing. Simply you have assigned a lambda expression to this particular functional interface variable. Now when this will be executed? Functional interface dot object reference dot method name. Return person type is a method name here, and here it is a increment by 5 name. What value you are passing? 22. Here you are passing 22. Okay, so let me execute this. So see here, it is Boolean value either true or false, and this is even number. Any doubts so far? Okay, next. Okay, return a lambda expression from a method. We are trying to return a lambda expression. Public class, public static void main, perform that calculate, same thing. 2 comma 2 means calculate should be a abstract method. So here is a abstract method, calculate. And same like this is calculator part only, same like this example, but here we have taken only one calculate method. Here we have taken 4 times different type of expressions we have seen in this example, but in the previous example, whatever lambda return type, here we are taking only one, that is division operation we are trying to execute. Let's say this one. Okay, now you remember we worked with collections, list, array list, and we use iterator to iterate through the collection object. Okay, so this is a old style of writing this. See, now we have replaced it with lambda expression. Just with a single line, we are replacing almost 4 lines of code. Previously, we used to access like this. We call an iterator and then we execute. On the list, we are calling iterator. Iterator is nothing but an object which will traverse through the collection. So iterator dot has next, system.out.println next. So this is a old style. If you execute, you get the output. Okay. Now with Java 8, we can write simply names dot for each. Now this is a functional interface of type consumer. Functional interface of type consumer. Okay, so this is a function interface of type consumer. So names dot for each value for each method means inside the names. What is names here? List object. Names dot for each of name means any variable you can give. If there is a variable, you are passing a variable system.out.println. Means if there are any values in the list, you please print them. If there is any value, you assign it to the variable called name and print that variable. That's it. This is an interface of type consumer. What is a consumer? Consumer will read the value. Consumer will consume the value. Yes or no? Consumer will consume the value. So here it is consuming from the list. It is consuming from the list. For each value inside the list, you please give me the value. So that is the meaning of consumer. Is this point clear? Go through the program. Let me know if you have any doubts. This is of type consumer. Means consumer will consume the value. Functional interface is consuming the value. Who is a producer? List is a producer. List is a producer and functional interface is a consumer. It is consuming the values from the list. See, two times it is printing.
Hello.
All right, so now let's see another example. So this is also an example of consumer type. We are taking a list and we are adding countries. This is using Again, same type. Consumer type. List dot for each of country name. Print the country name. If at all we don't use a lambda expression, see we have to use like this. There's a difference between using a lambda expression or else for loop.
You're talking anything? I'm not able to hear.
Yeah, 1 second, just observe this program.
Okay.
So if you observe, there is much difference from the previous program. So instead of iterator, we are using a for each loop. So for each of object, we know a collection object returns a value of type object. So for every object in the list, print the object. Explicitly, we have to typecast and then print it. Okay. Now this entire part is replaced with this part, lambda expression. So this way we say lambda expressions reduces code length. Lambda expression reduces lot of boilerplate code. Okay. So this is the output. Again, this is a consumer test for each. So you're creating a person class. You're creating a person and calling setters and getters. Person constructor, setters and getters. And class message you have. Person is a different class, message is a different class. And you're trying to use both of them here. message equal to new message. So creating a message object, creating a person object. Now here see consumer, predefined consumer. This is functional interface is a predefined, consumer is a predefined functional interface. Message consumer, we are just simply passing t variable and printing the t. Message consumer dot accept. Now where is this accept coming from? Accept is a predefined method available in consumer interface. Available in consumer interface. See, consumer is a functional interface which is available in function package. java.util.function.consumer. Okay, so to this consumer we can create our own objects. Message consumer I am creating, and what I am passing t and printing t simply. Okay, now how to execute this? I have to call a method of functional interface. Now what is the functional interface name? Consumer. Now what is a method that is available? Accept message. So message consumer dot accept I have to call. Okay, so here lambda will be executed. Now what is the message that you are passing? This message object you are passing, which you have created, means passing user defined objects. That is a criteria here. Passing user defined objects as parameters. You are passing a user defined object as a lambda parameter here. Parameter to the function interface. Okay, so if you pass this message, then this will be passed to t and then it will be printed. Same is the case with the person consumer. Okay, so consumer is a predefined functional interface which is having accept as a functional method. Are we clear so far? Just observe the code. See, this is a person details, it's a message details, person and message. So we are passing. So far we have seen passing numeric values, string values as a lambda parameters. But now we are passing a user defined object as a lambda parameter. Is this point clear?
Yeah.
Any doubts in this?
Any doubts in this?
Any further clarifications required?
No, I am good here. Yeah.
All right, okay.
Yeah.
All right. So shall we continue tomorrow? Because we have few more interviews.
Yeah, sure. Yeah.
We have few more interviews. It will be too much. We will continue tomorrow.
Okay. Thanks.